for grad students. One is it's free, right? Which that's always a nice thing. So, the hope is by getting involved with the Center for High Throughput Computing, you can use systems like Condor to help your research, write better papers, get more recognition. So I have a couple, thank yous are up there. This is a guy that, gave him over a weekend. This grad student got 15,000 CPU hours. Here's another graduate student. He used about 70,000 CPU hours for his paper. In the computer science department, we have a pretty decent architecture group. And what's kind of cool about it is the architecture group, they need a lot of simulation time, right? They're simulating a MIPS CPU or some kind of CPU in software. Each instruction might take 5 minutes or something like this to run. They're changing different pipeline structs, different caching. And, they could show up at conferences and it's like, oh yeah, we ran, we tried out our new idea for pipelining on real programs, in simulation that ran for a clock time of an hour, right? And everybody else at the conference is there and, their simulator ran for, 10 seconds or something like this. So, what is the Condor project? It's a research project in computer science. We cover a lot of ground. So one thing we make is we make software, which is the Condor software, which of course now that I'm just about done with the motherhood and apple pie, I'm going to start talking about. But one thing that's a little interesting about it is it straddles kind of research and production software, which has sometimes been tough. Right? On the one hand, the research side of Condor always wants to put new things in the software and let's try new things and let's see how it works and whatnot. And then we have a lot of users in production that are like, don't change anything. So it's quite the software engineering effort. So the Condor project has been around since '85. Started Professor Marone Livni. That's him. I'm guessing a picture taken in '85 by the looks of it. Condor survived the mullet days of the early '80s. That's me sitting on a Sun Spark 1, actually, at the Computer Aided Engineering Center. It survived the big hair days of the late '80s. This is a guy who works on the Condor project, who does a lot of the process migration and checkpointing. And it's, still around here in the slick black turtleneck Steve Jobs iPhone days. This was us in '98. This is us in 2007. Quite a bit bigger. So the Condor project does a lot more than write the Condor software. We're involved in research in a lot of different areas. So what the heck is the Condor software? So it's open source distributed computing software that takes collections of distributively owned machines and converts them into a high throughput computing facility. And it manages resources and machines and blah, 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 blah. What does it do, like, in a nutshell, right? You have your program. You need to run it somewhere. Maybe you want to run it 100,000 times. You submit it to Condor. Condor looks out over a network and decides where to run it and runs it. Okay? So this is my, oh, that'd be easy guy. That doesn't sound very hard, right? Why is there this huge research group that's been cruising around since the 80s working on this? Couldn't I just take Perl, give me your A dot out, Perl could randomly pick a machine, SSH, run it there, and job done, right? I had someone ask me that at one point. Yeah, you could, I guess, but your Perl script would probably grow really, really large, really fast if you actually tackled some of the hard problems. So, what are some of the hard problems? You would have scheduling issues. Okay, what if all the machines that your Perl script was going to SSH to weren't the same? Some of them had different disk space or connected to different networks. I know you guys had a talk about GPUs recently. Maybe some of them had GPUs, some of them didn't. So what if you didn't have a nice homogeneous network? You would have to pick and choose which ones to use and how to do that efficiently. What if your program needed parallel? You needed more than one CPU. You needed multiple CPUs. Do you grab multiple ones all at once? How do you then prevent starvation? Right? If I've only got 10 machines and I've got an infinite number of jobs that only need one machine, and then I submit a job that needs 6 machines. When will there ever be 6 machines free at any given moment, right? If everybody else is submitting one jobs, right? Or how do you prevent deadlock? I've got 10 machines, and at the same time, 2 users submit jobs that both need 8 machines. If you grab them one at a time, it could be job 1 will grab 5 machines, job 2 will grab 5 machines, and then they'll both sit around waiting forever for more machines to show up. Issues like that. What if there's software licenses to be managed? What if you need to do gang matching, where you need to schedule not just a machine, but you need to schedule at the same time a software license and network space and database access and whatnot? More than one resource is required by your job. Fair share. What if your Perl script gets so popular there's lots of users that want to use it at the same time? Such that you have more jobs or more users than you have machines. Who gets to go next, right? How do you keep track of that? What if your jobs, you no longer have an A.out, but you have a workflow? So by a workflow, I mean you have lots of programs, and when those programs are done, they need to submit lots of other programs, and you have interdependencies between the jobs. There's issues of security. So security goes both ways, right? You need to protect the people that own the machines, right? You don't want jobs to run that get root access on the machine or start killing off other people's processes or leave things behind. On the flip side, you need to protect the people submitting jobs as well, right? It'd be pretty mean if I worked on my simulation code, submitted it to a system like Condor, and somebody could fake results or spoof results that I got back. What if you wanted to leverage across administrative domains? So what do I mean by administrative domains? I mean, what if you don't control all the computers that you're trying to use? Okay, so things to think about here are, for instance, I have at the bottom data access, right? Even on this campus, there's computer science and there's computer-aided engineering center, and there is no shared file system stuff really between them at all, right? I mean, yeah, there's kind of AFS, but we could talk about that. So Mr. That was easy says, okay, I'll tackle data access. That's not so bad. You give me your program, and I'll wrap it in a little shell script here. People here know Bourne shell a little bit, yeah. So I'll wrap it in the shell script. People will just dump their input files into NFS. We'll call it /work/foo. And when the program starts up, I'll erase any old data, in this directory, and I'll wget your new data from someplace, and then run your program. No problem. And oftentimes when you run a program once or whatever, there isn't a problem. But if your Perl script gets popular, right, people will be submitting thousands and thousands and thousands of jobs, right, and hundreds of users. And I guarantee you that Murphy's Law is really a law, and it gets you every single time. I mentioned maybe /work is maybe on an NFS partition. Who here has had the joy of trying to use a machine when the NFS server is temporarily down? Yep. You can't CD into the directory. It's a big pain. Now imagine you started up 5,000 jobs that pounded on the NFS server all at once, right? What do you think the odds are of the NFS server surviving? And that probably not too good. So we got to worry about what if /work foo is not available. All right. So I know Bourne shell. No problem. So. We'll try to CD in there a bunch of times. If the CD fails based on the exit status, we'll sleep a little while. We'll try again. You know, and if we tried more than some number of times, we'll return with a different exit status and bail. So realize